Hi, all. It is argued that the greatest achievement of the human intellect is calculus. I agree with this argument. Behind every technology, from sending a rocket into space to manufacturing a pin, there is the workings of calculus. Feynman calls calculus the spoken language of God. They say that at the heart of calculus lies the concept of limit. Unfortunately, there is no other concept in mathematics which evokes as much confusion and fear as the limit concept does. This is because of the strange symbols and conditions in which the concept of limit is expressed. I always feel that the biggest source of math phobia at all levels, from schooling to research, is symbolism. But I claim that limit concept is as easy as any other concept in mathematics provided we approach it the right way. I shall try to do that in this talk. Understanding limit concept is real power. As Greeks told to Romans that knowledge is power. I shall first clarify the position of limit concept in mathematics and then explain what is meant by limit. All calculus is, quite simply, finding the derivatives and integrals of some particular real functions and applying their properties to real world situations. Now, what does this mean? I explained elsewhere the meaning of the word quantity. I also said that some quantities depend on some other quantities. If quantity A depends on quantity B, it means that as B changes, A also changes. If A changes with B in not an irregular way, and we know how exactly A changes with B, then it is possible to find exactly two things. Firstly, the rate of change of A at any value of B. I will explain this expression rate of change shortly. Secondly, it is possible to find the total product of A and B even though A is not constant but continuously changing with B. These two things are given the names derivative and integral. The exact dependence of one quantity on the other is given the name function. We shall discuss the exact meanings of derivative and integral in other talks. Even though this concept of derivative and integral are providing solutions to large and varied problems in shortest time and simple means, the lack of precise definitions for derivative and integral raised both logical and ethical problems. A famous essay by a priest called Berkeley criticized mathematicians and scientists that their methods are not better than the methods of religion based on faith. To address the issues raised by Berkeley, many mathematicians tried to provide clear definitions for derivative and integral after using them for more than 200 years. That is why it is famously said that the derivative was first used and then discovered and then defined. Today, using anything in mathematics without first defining it would be deemed unethical and invalid. Lagrange tried to define both derivative and integral as infinite series, but his project failed. Cauchy introduced the concept of limit and succeeded in showing that the derivative and integrals are both limits. Derivative, a limit of a real function, and integral, a limit of a sequence. Please remember that the definition of limit of real function can be defined through the definition of limit of sequence. So defining the limit of a sequence is the very key for proper understanding of limit concept. Different sequences behave in different ways, and I shall first define what is called as converging sequence. Understanding the concept of converging sequence is really at the heart of understanding limit concept and also some other things like defining Euler number, measuring probabilities of infinite sample spaces, etc. The definition of limit, which originated in that one famous historical sentence of Cauchy, was consolidated by Weierstrass after 5 decades in what is today called the epsilon delta definition of limit, found in all textbooks today, scaring us. As a personal note, I am a great fan of Weierstrass. Dunham says he is the Cinderella of mathematics. In the next talk, I shall be doing 4 things. Define converging sequence, define limit of a real function in terms of definition of converging sequence, show how this definition leads to Weierstrass epsilon delta notation, and finally show how this new symbolism is used to represent other behaviors of sequences and real functions. Thank you.